Hello learners, what is NumPy? NumPy stands for Numeric Python, which is a Python package for the computation and processing of the multi-dimensional and single-dimensional array elements. Travis Oliphant created NumPy package in 2005 by injecting the features of the ancestor module numeric into another module numarray. It is an extension module of Python which is mostly written in C. It provides various functions which can perform numeric computations at a high speed. NumPy provides various powerful data structures, implementing multidimensional arrays and matrices. These data structures are used for the optimal computations regarding arrays and matrices. In this session, we will go through the numeric Python library NumPy. The need of NumPy. With the revolution of data science, data analytics, libraries like NumPy, SciPy, Pandas, etc. have seen a lot of growth. With a much easier syntax than other programming languages, Python is the first choice language for the data scientists. NumPy provides a convenient and efficient way to handle the vast amount of data. NumPy is also very convenient with matrix multiplication and data reshaping. NumPy is fast, that makes it reasonable to work with a large set of data. There are following advantages of using NumPy for data analysis. NumPy performs array-oriented computing. It efficiently implements the multidimensional arrays. It performs scientific computations. It can perform Fourier transform and reshaping the data stored in multidimensional arrays. NumPy provides the inbuilt functions for linear algebra and random number generation. Nowadays, NumPy in combination with SciPy and Matplotlib is used as the replacement to MATLAB, as Python is more complete and easier programming language than MATLAB. Prerequisite. Before learning Python NumPy, you must have the basic knowledge of Python concepts. NumPy environment setup. NumPy does not come bundled with Python. We must install it using the Python pip installer. Execute the following command. Pip install NumPy. It is best practice to install NumPy with the full SciPy stack. The binary distribution of the SciPy stack is specific to the operating systems. Windows. On the Windows operating system, the SciPy stack is provided by the Anaconda, which is a free distribution of the Python SciPy package. It can be downloaded from the official website of Anaconda. It is also available for Linux and Mac. The Canopy also comes with the full SciPy stack, which is available as free as well as commercial license. We can download it by visiting the following link. The Python x, y in the brackets is also available free with the full SciPy distribution. Downloaded by visiting the link of GitHub. NumPy ND-array. ND-array is the n-dimensional array object defined in the NumPy which stores the collection of similar types of elements. In other words, we can define an ND-array as the collection of the data types, D-type objects. The ND-array object can be accessed by using the zero-based indexing. Each element of the array object contains the same size in the memory, creating a ND-array object. The ND-array object can be created by using the array routine of the NumPy module. For this purpose, we need to import the NumPy. For example, import NumPy as np, a is equals to np.array, print a in the brackets, output, built-in function array. We can also pass a collection object into the array routine to create the equivalent n-dimensional array. The syntax is given below. NumPy.array object comma d type is equals to none, comma copy is equals to true, order is equals to none, sub ok is equals to false, ndmin is equals to 0 as parameters to the function. The parameters are described in the following table. To create an array using the list, use the following syntax. A is equals to numpy.array 1, 2, 3 within square brackets passed to the function. To create a multi-dimensional array object, use the following syntax. A is equals to numpy.array 1, 2, 3 within square brackets, comma 4, 5, 6 within another square brackets passed as parameters to the method. To change the data type of the array elements, mention the name of the data type along with the collection. A is equals to numpy.array 1, 3, 5, 7 within square brackets, comma, complex as parameters to the array method. To change the data type of the array elements, mention the name of the data type along with the collection. A is equals to numpy.array 1, 3, 5, 7 within square brackets, comma, complex as parameters to the method. Finding the dimensions of the array. The ndim function can be used to find the dimensions of the array. Import numpy as np. arr is equals to np.array. The following digits are passed as parameters to the method. Print arr.ndim. Finding the size of each array element. The item size function is used to get the size of each array item. It returns the number of bytes taken by each array element. Consider the following example. Example, comment, finding the size of each item in the array. Import numpy as np. A is equals to np.array 1, 2, 3 within square brackets, passed as parameters to the array method. Print within double quotes, each item contains, comma, a.item size, comma, bytes in double quotes. Output, each item contains 8 bytes. Finding the data type of each array item. To check the data type of each array item, the dtype function is used. Consider the following example to check the data type of the array items. Example, comment, finding the data type of each array item. Import numpy as np. A is equals to np.array 1, 2, 3 within square brackets passed as parameters to the array function. Print within double quotes, each item is of the type, comma, a.dtype. Output, each item is of the type int 64. Finding the shape and size of the array. To get the shape and size of the array, the size and shape function associated with the numpy array is used. Consider the following example. Example, import numpy as np. A is equals to np.array. The following digits are given as parameters to the method of array. Print within double quotes, array size is, comma, a.size. Print within double quotes, shape is, comma, a.shape. Output, array size is 7, shape 1, 7. Reshaping the array objects. By the shape of the array, we mean the number of rows and columns of a multi-dimensional array. However, the NumPy module provides us a way to reshape the array by changing the number of rows and columns of the multi-dimensional array. The reshape function associated with the ndArray object is used to reshape the array. It accepts the two parameters indicating the rows and columns of the new shape of the array. Let's reshape the array given in the following image. Example, import numpy as np. A is equals to np.array. The following pairs of numbers within square brackets as parameters to the array function. Print within double quotes, printing the original array. Print a. A is equals to a.reshape 2, 3 as parameters to the reshape function. Print, printing the reshaped array within double quotes. Print a. Output, printing the original array. Printing the reshaped array. Slicing in the array. Slicing in the NumPy array is the way to extract a range of elements from an array. Slicing in the array is performed in the same way as it is performed in the Python list. Consider the following example to print a particular element of the array. Example, import numpy as np. A is equals to np.array. The following pairs of numbers as parameters to the array function. Print a 0, 1 within square brackets. Print a 2, 0 within square brackets. Output is, the above program prints the second element from the 0th index and 0th element from the second index of the array, finding the maximum, minimum and sum of the array elements. The NumPy provides the max function, min function and sum functions which are used to find the maximum, minimum and sum of the array elements respectively. Consider the following example. Import numpy as np. A is equals to np.array with following numbers as parameters to the array method. Print within double quotes the array, comma a. Print the maximum element is within double quotes, comma a.max function. Print the minimum element is within double quotes, comma a.min function. Print the sum of the elements within double quotes, comma, a dot sum function. Output, the array is, the maximum element is, the minimum element is, and the sum of the elements is. NumPy array axis. A NumPy multidimensional array is represented by the axis where axis 0 represents the column and axis 1 represents the rows. We can mention the axis to perform row level or column level calculations like the addition of row or column elements. To calculate the maximum elements among each column, the minimum element among each row, and the addition of all the row elements, consider the following example. Import NumPy as np, a is equals to np.array. The following set of numbers are passed as parameters to the array method. Print the array is within double quotes, comma, a. Print the maximum elements of columns is within double quotes, comma, a dot max function, axis equals to 0 as parameter to the max function. Print the minimum element of rows within double quotes, comma, a dot min, axis equals to 1 as parameter to the min function. Print the sum of all rows within double quotes, comma, a dot sum, axis equals to 1 as parameter to the sum function. Output is the array, the maximum elements of columns, the minimum element of rows, the sum of all rows. Finding square root and standard deviation. The square root and std functions associated with the NumPy array are used to find the square root and standard deviation of the array elements respectively. Standard deviation means how much each element of the array varies from the mean value of the NumPy array. Consider the following example. Import NumPy as np, a is equals to np.array with the following numbers passed as parameters to the array method. Print np.square root of a, print np.std of a. The output is arithmetic operations on the array. The NumPy module allows us to perform the arithmetic operations on multidimensional arrays directly. In the following example, the arithmetic operations are performed on the two multidimensional arrays A and B. Example, import NumPy as np, A is equals to np.array. The following numbers within square brackets are passed as parameters to the array function. B is equals to np.array. Similarly, the following numbers have been passed as parameters to the array function. Print sum of array A and B, next line within double quotes, comma, A plus B. Print product of array A and B, next line within double quotes, comma, A asterisk B. Print division of array A and B, next line within double quotes, comma, A divided by B. Array concatenation. The NumPy provides us with the vertical stacking and horizontal stacking that allows us to concatenate two multidimensional arrays vertically or horizontally. Consider the following example. Example, import NumPy as np, A is equals to np.array with numbers passed as parameters to the array function. B is equals to np.array, following numbers passed as parameters to the array function. Print array is vertically concatenated, next line within double quotes, comma, np.vstack, a, comma, b passed to the vstack function. Print array is horizontally concatenated, next line within double quotes, comma, np.edstack, a, comma, b as parameters passed to the edstack function. Output, arrays vertically concatenated are, arrays horizontally concatenated are. Here, this session comes to the end. Hope you are enjoying the course. Thanks for watching this video.